Good afternoon, one and all. My project's title is Music Recommender System. So in this project, I have analyzed two techniques, that is collaborative filtering technique and content-based filtering. These are the two techniques which are used by world's largest conglomerates such as Spotify, JioSaavn, YouTube, etc. So first, let me run the project's UI. So as you can see, I have run a command like python source /manage.py, so it will redirect me to Spotify's authentication. So in the collaborating filtering part, I have used Spotify API. The Spotify API enables me to use its songs and playlist, and the dataset is coming live from Spotify. The dataset is real time, so I don't have to pick up dataset from any site like Kaggle or any other site for that matter. So now as you can see, the Spotify has accessed and said yes to the authentication, and now I'm going to run the project. So as you can see, I'm already logged in my project. So there are various features in the project like home, playlist, analyzer, changing the password, changing the email, changing profile, etc, etc. And also you can change the language as well. I have enabled 3 options: Russian, Chinese and English. All of this has been deployed on Django. So as you can see, as I click on the playlist, my playlist is these playlists. So all of these playlists are the playlists which are on my Spotify account. So if I click on any of these playlists, it will open on Spotify. As you can see, it will open on Spotify. So this is the playlist which is in my account. All of this Adrenaline Rush or Calming Bollywood Songs by Nitika Medha, all of these is in the Spotify playlist. So if I go to the analyzer, and now analyzer is the integral part of my project. Like from here I can get the training data set, get the test data set, get recommendation and view the test data. Now as I click on the get training data set, the API will make request to the Spotify API. The Spotify API will enable or grant my request as I am a Spotify developer. When you become a Spotify developer, it enables you to use their songs on your project. You have to mention the reason, if it is going to be commercial or just for your project. So I have not mentioned commercial since it is running on localhost. So when you become a Spotify developer, you get this, the username which is on my Spotify account, and also you get client secret key and client ID. Now these ID are essential for connecting to the API as they enable us to connect to the host, and the data set comes live from there. So if I click on get training dataset, I'll get the training dataset live from there. So I've already done it, because if I do this right now, it will take hours and the request can get exhausted as well. So I will show you the training dataset. Here it is. So this is the artist name, track, acoustability, danceability, energy, instrumentalness, liveliness, loudness. All of these components have been extracted from Spotify. All of these values are there from Spotify itself. This is the name of the artist. And for the test data set, if I click on the get test data set, it will again show me this. So if I click on view test data, it will show me like this. This is the name of the artist. This is the artist ID which is officially given by Spotify. These are the IDs which are given by Spotify to the artist. These are unique IDs for every artist. So you can see Marshmallow has this ID and Love has this ID. So this is the track by the artist. This is the features. These are the feature vectors. That is the acousticness, danceability, energy, instrumentalness, key, liveliness, loudness, and all of these features Spotify provides us with. So I'm getting a data set which is real time. So if I'm going to run this recommender 1 year from now, it will still be fresh. It will not degrade or degenerate or get old as the time progresses. So it will maintain its value over time. So if I click on get recommendations, now what will happen is my model will run in the backend. So now it's the time to show you my model. So the Spotify enables us to use the API through a library called Spotify. Spotify is a library which is used for extracting data from the Spotify service. So in this case, I have loaded these three libraries: NumPy, Pandas, Spotify, training data, etc. from Jupyter, and I'm running this in Jupyter. So for this, I'm going to use support vector machines. Now, support vector machines enables us to use it for high dimensional data, and it is perfect for this data set. I have used decision function probabilities and the probability function for checking out the similarity between songs. This means that I will be getting the songs which are closer to what the user listens to. I will be recommending artists which are closer. Like, the recommendation works on the parameter that if something is similar to another, it will be recommended. So that is what support vector machine provides us with. It provides us with a decision function which provides me with a list of probabilities. So if I go down here, I've already run it for convenience. So these are the decision function values. So as close as they are to the original function, the more likely the song is to be getting recommended. So at the end, I recommend these songs to the user. So Lorde is the artist name, and this is his perfect ID, which is given by Spotify. So this is how my model works on the collaborating filtering part. The second part of the project comes under the content-based filtering part. So in my project, I analyzed two techniques against one another, which is the content-based filtering and the collaborating-based filtering. In the content-based filtering part, I chose a dataset called GTZAN dataset. In GTZAN dataset, I have 10 genres to choose from. Like, those are MP3 files. So first, what I do is I show you the dataset. So here you can see blues, classical, country, disco, hip hop, jazz, metal. These are the 10 genres which the music provides with, and it has 8,000 tracks. So as you can see, these are the WAV files. All of these are WAV files, and these are music files. These are not any CSV kind of file, comma separated values. No, they are not like that. These are music files. So what I do is I conduct analysis on them based on a library called Librosa. Librosa enables us to extract spectrograms from them. So let me just show you the content-based filtering part. So this is a content-based. I loaded the libraries Librosa, Pandas, Keras. I've used artificial neural network in this. So these are the 10 genres that I'm trying to classify. And these are the 5 parameters that I'm going to use in order to identify the genres. So that is the root mean square error, the spectral centroid, the spectral bandwidth, roll-off, and zero crossing rate, as well as MFCC values. So as you can see, I have converted this into a dataset, all the information about the songs. So if I show you the spectrograms that I converted with the help of Librosa, they come here. So for all the 10 genres, it has converted all of these songs into these Smell spectrograms. So Smell spectrograms basically show how the frequency is changing over time. So if you see for classical, it is showing this. It is a different pattern. And if I show for the pop song, it is definitely darker than the previous image that I showed. So that is how spectrograms are the best to analyze songs and the audio files for that matter. So what I've basically done is I have label encoded all of these. Why label encoding was needed? Because I had 10 genres, so that is why I needed it. And standard scaler is used because I don't want the system to be confused between these genres, because it may consider the genre labeled as 9th being greater than the one which is 7th. So that is why we do standard scaling. I've used a neural network here. So the first layer is the sequential one, and then I add layers subsequently with the input shape as 256, and I drop out at 0.2 in each and every layer, and the accuracy comes out to be around 68.3%, and that I ran for 10 epochs, and the testing accuracy also came around 68%. Now if I use this to predict, so if the genre label 2 was predicted as 2 and the genre label 5, as I can see, was labeled as 7, so that is something the system is unable to identify. Since the accuracy of identifying the genre, that is came out to be 68.3%, it is lesser than what we expected, because if I reduce the genres, the accuracy will definitely increase. But then if the user gives me a song in a different genre, let's say I had not identified a pop song and a user wants a similar songs to the pop, then it will not identify. And if I use 9 genres, the accuracy came out to be 68.3%. So that is something that I do not want. I do not want the system to get crash or malfunction due to genre not being classified properly. So that is why I didn't go ahead with the content-based filtering system, and I got ahead with the collaborating filtering part. For that, I've already shown you the UI. So as I can see, in the meantime, the recommendation got successful, and these are the recommendations. So Lucas is the artist name, Maltroda, JP Cooper, Camilla Cabello, Billy Kenny, Liam Payne. So these are the artists and their artist ID according to Spotify. So if I click on this, it will show me their songs. Live Forever, First Time. So that is how the artist is getting recommended. We are using the decision function for calculating the most similar probability to our user's song. So that is how my system works, and thank you everyone.